No. If you want to go, I'm gonna send you this stuff anyway. So, all right. So that's the end of section 2. Now we're gonna do chapter 8, section 3, trig integrals. Day 19, Tuesday. We'll be looking at integrals of this form. Because everything can be written down in terms of sine and cosine. So this is what we're going to look at, the sine and cosine. When this occurs, where our exponents are non-negative numbers. They can be 0 because if it's 0, then it just becomes 1. So you can do the same thing with the cosine we just had. So we get the same answer we had last time. So when this occurs, when you have this form, we have 3 cases possible. We could have, here's case 1. If m is odd, if that's the case, then we write m as 2k plus 1. That's going to be this. If k is any integer times 2 is even, when you add 1, it's going to be odd. We use the identity sine squared x equals 1 minus cosine squared x. To get this formula. Sine mx is equal to sine, remember m if it's odd is 2k plus 1, which is equal to sine squared x to the power k, then plus 1 sine x. Remember the rules of exponents. If you have the same bases, then you add the exponents. So we have 2 times k plus 1, which is that. So we can split it up that way. Now, sine squared is 1 minus cosine squared x to the power k x. So when m is odd, we use this formula. Case number 2. If n is odd, because remember, n is the exponent of the cosine function. If n is odd, then we write n as 2k plus 1. And we use the identity we used above, but for this time it's cosine squared x equals 1 minus sine squared x. So what we have here is this. Our formula is to get cosine nx is equal to cosine 2k plus 1, which is x, which is equal to cosine squared x to the power k times cosine x. Cosine squared is 1 minus sine squared x to the power k cosine x. Oh, yeah, I forgot something here. This we combine this, the single term here, these single terms, because there's going to be a dx because we'll be looking at integrals. And for that, we write this becomes d sine x. This one becomes d cosine x. No, d sine x. I'm sorry. This is cosine. This derivative, because this is the integral, so the derivative of negative cosine is the sine. The derivative of sine is cosine. So the integral of cosine is sine, yeah. And case 3, if both m and n are even in this formula, so we have sine mx cosine nx dx, we can use sine squared x is equal to 1 minus cosine squared x, and cosine squared x equals 1 minus sine squared x. And with our identities, we can have 1 minus cosine 2x over 2. And this is 1 plus cosine 2x over 2. The reason we do that because if it's even, that means it's a multiple of 2. So then let's say it's a power 4, then we'll have sine squared in parentheses squared. So it'll be this equation squared. So that's what we're looking for. And if you notice here, what's also happening here, what we did last chat section, we're going from an exponent to no exponent. So it's a power reduction formula. And here you have them. That I have the sheets here, but I'll include them in the upload. So here's all the rules. So our first example. Example 1. Well, I'll do it on the sheet. The integral of sine cubed x cosine squared x dx. No, it's a good question. I'm sorry it took me so long to answer. To recognize the difference between u and v, the u is going to be the one you differentiate. You take derivatives of. So the one that's easiest to, when you take derivatives, it'll eventually go down to zero. Like if you have x to the fourth, if you use x to the 4x to the third, 12x to the second, and you keep going that way. So, and the v, that's the one that's easily integrable. The ones you take integrals of it. So that's how you differentiate the u and the v when you look at these equations. All right, so let's look at this example. Yeah, because I have the sheets here. They're here, but there's not enough room. It's only this much, so I'll use it on my scratch paper. So we notice here that m is odd. So we use case one. Case one is if m is odd, we change it to 2k plus 1, and we can rewrite it as that. So what we can do, we can take this and knock it down this way. And then we have sine x dx. Remember, sine x dx is equal to negative d cosine x. Ugh, that's horrible. Negative d cosine x. And we know sine squared x is 1 minus cosine squared x times cosine squared x times negative d cosine x. All right, so put that in parentheses. Because the sine x dx became that. All right, so now we have a lot of cosines in there. So we have u, let's do substitution. U is equal to cosine squared x. That way we have 1 minus, look at 1 minus, what cosine? So 1 minus u squared negative du. So we have u squared minus u to the fourth negative du. So I'll multiply this into both of them. So I have negative u squared du plus u fourth du makes it negative u squared du plus u to the fourth du. And that comes the easy part. So we have the integral of u squared is u3 over 3, u5 over 5 plus c. So anywhere you see a u, put a cosine. So it's negative cosine cubed x over 3 plus cosine 5x over 5 plus c. And there's your answer. There's the integral of that function. And here's the example 2. I'll start doing on these now. I have more room. Evaluate cosine to the 5th. Cosine deals with the n, so here n is odd. Notice there's no sine. Ooh, that's horrible. So the m is 0. Remember, the exponents m and n can be anything greater than equal to 0. So sine of 0 is 1. So all we have here is n is our odd function. So we could break that one down. So our integral of cosine 5th of x dx is the integral of cosine 4x times cosine x dx. Remember, cosine x dx is equal to d sine of x. So this is cosine squared x squared d sine of x. One minus sine squared of x squared d sine of x. Since we have sine everywhere, we'll define u as sine x. And that'll give us 1 minus u squared squared du. This is a 1 minus u squared squared 1 minus u squared times 1 minus u squared becomes 1 minus 2u squared plus u to the 4th. 1 minus 2u squared plus u to the 4th du. Now I can just do each one of those separately. Integral of 1 is u. No, that takes care of the du. U cubed over 3. U to the 5th over 5 plus c. So sine x minus 2 sine cube x over 3 plus sine to the 5th x over 5 plus c. And there's that answer. It makes it much easier once you do the substitution and then just put it back in the back at the end. It makes it much easier to do it that way. All right, let's look at number 3. Where's example 3? Here it is. Evaluate this one. So we have integral of sine squared x cosine to the 4th x dx. M and n are both even, so this is a case 3 example. If you remember what we had, sine squared x was equal to 1 minus cosine 2x over 2, and cosine squared x equals 1 plus cosine 2x over 2. Those identities, that's what we're going to do here. For this one, we have sine squared x already. This one's going to be cosine squared x squared. So this one is 1 minus cosine 2x over 2. This one is 1 plus cosine 2x. It's a power reduction. Okay, so we have 2 here, and that's 2 squared is 4. So we can take out a 1/8 here. Get rid of the denominator. So we have 1 minus cosine 2x, 1 plus cosine 2x squared dx. Combine these two. I got to go ahead and square this one first. 1 minus cosine 2x. So this is 1 plus cosine 2x times 1 plus cosine 2x. I got to FOIL those out. I get 1 plus 2 cosine 2x plus cosine squared 2x. And now I got to distribute all those. Get rid of the parentheses. So 1 times 1 is 1 plus 2 cosine 2x plus cosine squared 2x. Now this one, minus cosine 2x minus 2 cosine squared 2x minus cosine cubed 2x dx. That's combined terms. So we have 1, 2 cosine 2x minus cosine 2x is plus cosine 2x. So that takes care of those two guys. 1 cosine squared x minus 2 cosine squared x is minus 1 cosine squared 2x. Then minus cosine 3 2x dx. Since these have powers, these first ones are going to be pretty easy. So we have the integral of 1 dx plus the integral of cosine 2x dx. Take out the minus sign. Cosine squared 2x plus cosine cubed 2x dx. Yeah, because they have to stay together because they have exponents. So we'll have to worry about those in a second. We'll treat each one of these separately. So, well, we can do that if you want to. Okay, yeah. So we distribute everybody separately. Integral of dx is x plus integral of cosine 2x, so it's the chain rule. Integral of cosine is sine. Integral of 2x no, we need this. There's a derivative. It's integral, so yeah, it's got to be over 2. So we have over 1 minus the integral of cosine squared x the squared 2x minus the integral of cosine 2x 2x dx. So these are finished. We just have to do those now. So example 3, last parts. So what we have to do is we have to find the integral of that and the integral of that. Cosine squared 2x dx and the integral of cosine cubed 2x dx. Once we find those, we put them both back in there and then we work it out. Cosine squared, we had cosine squared was a 1 plus cosine 2x over 2. Cosine 2x, and that's 2x, so it's 4x. And this one we break down to cosine squared x, cosine x, or 2x, I say. This is 1 minus sine squared x. Here, u is sine, and du is cosine. So we have, I'll get back to that in a second. 1 du minus integral of, let me switch them first. 1 minus u squared du. So the integral of du minus integral of u squared du is u minus u cubed over 3, which is sine x minus sine 2x. And then they should have 1/2 in front of them because of that 2x, so I should have a 1/2. Now back to this one. Yeah, that takes care of that. So we take the integral of 1 dx plus the integral of cosine 4x dx Integral of 1 is x. Integral is cosine 4x is sine 4x over 4, which is x over 2 plus sine 4x over 8. Okay, so now we put these two back in the other equation. Because we have the first part, these parts here, with the 1/8 in front of it. So what we had is 1/8 x plus sine 2x over 2 minus this one, which is x over 2 plus sine 4x over 8 minus this one. Sine 2x over 2, 2x over 2 plus c. Okay, so I have x over 8 plus sine 2x over 16 minus x over 16 minus sine 4x over 64 minus sine 2x over 16 minus sine cubed 2x over 16 plus c. We combine sine 2x minus sine 2x can combine. They're both gone. X over 8 minus x over 16. So this is 2 over 2 times that. So that becomes x over 16. Sine 4x over 64 minus sine cubed 2x over 16 plus c. There's the answer. What was here, I went ahead and distributed. That should be a plus. That should be a plus. Okay. All right. So that was number 3, example 3. Let me put example 4 up there. Hopefully we don't need another piece of paper here. I don't need that anymore, hopefully. Ooh, yes. Now, what if we have a radical in our equation? So in this next example, use the identity cosine squared equals 1 plus cosine 2x. It's a power reduction to help us eliminate the square root. So we have the integral from 0 to pi over 4 of 1 plus cosine 4x dx. Remember identity. We have cosine squared x is equal to 1 plus cosine 2x over 2. Because now we're going to look at theta. Yeah, so we're looking at theta. We're saying that theta is 2x. So we'll see. 1 plus 2 theta is the same thing as 4x. What's our identity for this one? Cosine squared x is equal to this identity. If we multiply both sides by 2, we have 2 cosine 2x equals 1 plus 2 cosine 2x, okay? Or theta. Okay. So inside here, we have 1 plus cosine 4x, 1 plus cosine. If theta is 2x, that's same thing as 1 plus that equals that. So 1 plus 2 cosine theta, which is 4x, 1 plus cosine 4x, I can rewrite that as 2 cosine squared x. Yeah, because we have to try to figure out how to make this thing a perfect square to get rid of it. Right, so this then becomes the integral of pi over 4 of 2 cosine squared 2x theta. All right, so we can split those up. Theta is 2x. Yeah, okay, good. So this is a constant. It goes out in front. The square root of cosine squared is simply cosine. You know why? Because our our bound is from 0 to pi over 4. From 0 to pi over 4, cosine is always positive, so we don't have to worry about absolute values or anything. So in other words, this is always going to be greater than 0. The integral of cosine 2x is sine 2x over 2 from 0 to pi over 4. sine 2 times pi over 4 over 2. I'll take that out there. Minus sine 2 times 0. So 2 and 4, so we have sine pi over 2. Sine of 0. Sine of 0 is 0. Sine pi over 2 is 1. So the answer is square root of 2 over 2. Yeah, the hardest part in this one is I got stuck on the very top. How can we rewrite this with one of the identities we know that this will become a squared term? So we have to eliminate the square. So cosine squared x is 1 is this identity. If we multiply by 2, we have that is 1 plus cosine 2 theta. If we say theta is 2x, then we have 1 plus cosine 4x, which means now we have that, which makes it 2x. That's theta. And when we put it back in there, it becomes 2x. Okay, example 5. Integrals of powers of tangent and secant. Okay, so we have tangent squared equals, so we have tangent squared x equals, its identity is secant squared minus 1. And we know that the identity of secant is tangent squared plus 1. We'll use the identities to help us out here. So evaluating tangent to the 4x dx. Okay, these are all in squares. So what we have here is tangent squared x times tangent squared x dx. Tangent squared x. And this one we'll write that as secant squared x minus 1. The reason being because we have to split them up and make them into smaller integrals that will be easier to integrate. All right, so let's distribute. We have tangent squared x times secant squared x minus integral of tangent squared x. These are both with dx. So for substitution, since we start off with tangent, let's try u as tangent. So the du of tangent is secant squared. Again, these are all on your cheat sheet. So what we have here is u squared du minus u squared can't do that one because we had nothing over here dx. So we have to go again. we have to now change tangent squared to secant squared x minus 1. So here we have u squared du minus the integral of secant squared x dx minus the minus makes it a plus 1 dx. Because these are straight off out of the book. It's just that this one we had trouble with. So the integral of u squared du is u over 3. The integral of secant squared is tangent. The integral of 1 is x plus c. So our final answer is tangent cubed x over 3 minus tangent x plus c. And that's our answer. That's our integral. All right, so let's look at that. Yeah, because we have no integral for tangent squared. So once we made our conversion here, the integral of secant squared is tangent. So if we converted this over, we have that and that easy integrals. Example 6. Here we can do it by parts because remember we have an odd exponent. So we can rewrite secant cubed x as secant x secant squared x. Now we can do it by parts. If we let u be secant, that's easy to take derivative of, and the dv make it secant squared. Because the integral of secant squared is tangent, and the derivative of secant is secant tangent dx. So by parts, let me find those. Remember, by parts, we have our formula is going to be uv prime is equal to uv minus the integral of v u prime. That's our formula for by parts. So we have our u and v's determined. So it becomes uv, which is secant x tangent x minus the integral of v, which is tangent, times u prime, which is secant x tangent x dx. This is similar to what we just did, because here we have two. So we have secant x tangent x. Tangent times tangent is tangent squared x secant x. And tangent squared from the last section was secant squared minus 1. Remember, this equals secant cubed x dx. The integral of secant cubed x dx. Because I'm putting those here because I'm seeing what's going to happen when I do that. Is going to be equals secant tangent x minus the integral of secant cubed x dx. And change that sign so it's plus the integral of secant x dx. So I'm distributing that integral time to it. All right, so since this is the same thing as here, I can move it over. I add this to both sides, so I have 2 secant cubed x dx is equal to the secant of x tangent x plus the integral of secant x dx. The integral of secant x secant x tangent x is ln secant x plus tangent x, I believe, plus c. And divide everybody by 2. So we have our solution. The secant cubed x dx is equal to the secant tangent over 2 plus ln of the secant x. I think it's plus tangent x over 2 plus c. And there's our answer. Okay. Looking at the sheets, we have 2 more examples left. Evaluate tangent to the 4th, secant to the 4th. Okay, the identity we're going to use here is secant squared x is equal to tangent squared x plus 1. So tangent 4 secant 4x dx is equal to the integral of the tangent 4th power the secant squared equals that tangent squared x plus 1 times secant squared dx, because that's secant squared, so I'll break those up. Okay, so here I can distribute. So I have tangent to the 6th x plus tangent to the 4th x secant squared x dx. distribute those. Tangent 6x secant squared x dx plus tangent 4x secant squared x dx. So here we use substitution again, so we have sine and cosine. So we'll make tangent x, the derivative of tangent is secant squared x dx. Because these are all our du's. So what we have here is u to the 6 du plus u to the 4th, because these are du's, which gives us u to the 7 over 7, u to the 5 over 5 plus c, which is tangent to the 7th over 7 plus tangent to the 5th over 5 plus c. That was a pretty easy one. Yeah, that's pretty straightforward, actually. Once we identify the identity we're dealing with. So again, use your cheat sheets and apply those identities. Products of sines and cosines. We're gonna see sine, 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 cosine, cosine, cosine. These are all three possibilities. If those happen, we can use these identities. All right, so whenever you deal with sine and cosines, you deal with periodic or oscillatory functions. They go up and down, up and down, up and down. All right, so we'll be using these identities. Yeah, these identities come from the angle sum formulas. So let's look at what do we have here. Evaluate this function. What do we have? We have integral of sine 3x cosine 5x dx. We have to use this one since we have a sine and cosine. So m is 3, n is 5. So we use that formula. Since 1/2 is a constant, I put out front. So I have sine m minus n x plus sine m plus n x dx. Sine of negative 2x plus sine of 8x dx. Since sine's an odd function as we write these, it's going to be sine of 8x minus sine of 2x dx. We'll take both of these separately. The integral of sine of a at x is cosine. This integral of sine is negative cosine a at x over 8. Integral of sine is cosine 2x over 2 plus c. Distribute that in there. We get negative cosine a at x over 16 minus cosine 2x over 4 plus c. No, the integral of sine is negative cosine, so that makes it a plus. So that is our answer. Again, that was just following the formulas. And once you finish the formulas, then just use the formulas. All right. Nope, that's 7, so we're done. That does it for section 3. All right, everybody, have a happy Halloween, be safe, and stay warm.